So think of what we're doing as forming your own open source strike team, Linux, Apache, MySQL, mariadb, and PHP assembling like the Avengers to deliver a reliable, inspectable web platform on a modest Raspberry Pi. Your scope isn't just make WordPress run. It's to build a stack you understand all the way down to process models, service boundaries, and file permissions, as well as HTTP request path. So when the plot twist arrives, and we all know it does, you're the one holding the Infinity Stones, not the one getting dusted. Start from a clean timeline and revert your Raspberry Pi to its original state. So your package repos, DNS rules, and IP tables aren't haunted by side quests from prior labs. Then do the hygiene that separates heroes from henchmen. Sudo apt update and sudo apt upgrade to align with the current metadata and security patches, because running latest.tar.gz on a stale libc is like fighting Ultron with a Nerf bat. Lamp, it's a classic garage band that never stops selling out arenas because each instrument still does its job absurdly well. Linux gives you the process model isolation and service orchestration you need. Systemd units define what runs, when, and under which identity. Journals and targets make startup deterministic. And repo hygiene, apt update, and upgrade keeps your tool chain patched instead of speedrunning CVEs. Think of Linux here as the soundboard. It routes signals, schedules CPU time, and enforces boundaries. When you later troubleshoot, you won't reboot and pray. You'll read unit status, review journals, and change only what the dependency graph demands. Apache is your front of house mixer. Battle tested, endlessly extensible. It terminates HTTP, negotiates keep alives, and routes requests to static files or dynamic handlers on our Raspberry Pi. Module choices and NPM do matter. Event NPM plus PHP-FPM is usually leaner and less memory hungry than prefork plus mod PHP. Modules like headers, rewrite, expires, and deflate are your pedal board, small toggles that shape the signal before it ever reaches the application. The logs, access, and error are your black box recorders. Tune formats to match your scene so you can ask grown-up questions later. MySQL MariaDB is the memory place for WordPress in our case. Posts, users, config all live here. Performance bottlenecks are more I/O than CPU on tiny ARM boards. Table design, indices, and query patterns matter more than raw gigahertz. Keep the server local and the connection a Unix socket when possible to dodge TCP overhead. Least privilege is non-negotiable. Grant a dedicated user only what WordPress needs on its database. Backups and point-in-time recovery aren't just enterprise cosplay. They're how you survive. Like, oops, I just nuked the options table. PHP is the runtime that turns the templates into HTML. With PHP-FPM, you get a long-lived pool of workers that amortize startup costs and enable per-pool isolation. On small hardware tune PM settings, max children and timeouts to avoid thrashing RAM. OPcache is your Jarvis. Caches compiled bytecode so you don't reparse the universe on every hit. Without it, WordPress will feel like dial-up. With it, CPU time shifts back to network and storage where it belongs. WordPress is our application layer that proves the stack. It's also where most its slow complaints originate from, usually because plugins multiply queries and block on remote calls. Treat themes and plugins like npm dependencies in a Marvel crossover. Each one adds runtime weight and potential plot holes. Use as few as you can, update often, and measure first. Lamp, it's a classic garage band that never stops selling out arenas because each instrument still does its job absurdly well. Linux gives you the process model isolation and service orchestration you need. Systemd units define what runs, when, and under which identity. Journals and targets make startup deterministic. And repo hygiene, apt update, and upgrade keeps your tool chain patched instead of speedrunning CVEs. Think of Linux here as the soundboard. It routes signals, schedules CPU time, and enforces boundaries. When you later troubleshoot, you won't reboot and think. Think like a defensive operator wiring a panic room, not a speedrunner mashing apt. The install order sets your blast radius and your rollback story. Start with the web edge, then the data plane, then the dynamic layer. On Debian, or in our case, Raspberry Pi OS, mariadb stands for the MySQL database. Semantics, so your WordPress brain still fits even if the badge on the engine says something completely different. Sudo apt update and sudo apt install option yes, Apache mariadb-server, PHP lib Apache 2 mod PHP, php-mysql is the command. Why? Why in this order? If Apache fails, you haven't opened a DB port or spawned PHP workers. If MariaDB chokes, your web tier still serves a 503 with receipts. If PHP misbehaves, static content keeps working and your error paths are visible. Now, you got to flip to verification because we're Batman with a packet sniffer, not the Joker with a bash history. So we start with our unit health. Are the daemons alive and enabled? System controller, systemctl status, Apache 2 MariaDB. Systemctl is enabled, Apache 2 and MariaDB. Journal CTL, option U, Apache, option U, MariaDB, since 15 minutes ago. Look for active, running, and clean recent logs. If they're not enabled, enable them so reboots don't erase your progress. So sudo systemctl enable Apache 2 enable MariaDB. Socket reality. Is it actually listening? SS option lntp grep 80 curl I http 127.0.0.1. You want to listen on port 80 that is owned by Apache 2 and an HTTP response with a sane status 200, 301, or 302. This proves the control plane systemd and data plane socket accept response are in the same universe. But then we've got our PHP runtime version modules and handler paths. PHP-v, PHP-m sort, echo, phpinfo, sudo t var www html info.php dev no curl option s http 127.0.0.1 info php head n5. PHP-v validates the interpreter. PHP-m confirms the modules. We're looking for MySQL and PDO MySQL. The phpinfo is a probe that proves Apache is handing PHP to PHP via mod PHP. If later you want to pivot to PHP-FPM, swap libapache 2 mod PHP for PHP-FPM and enable proxy FCGI. But for the time being, we're going to keep it simple and observable. Fourth, we have our database posture. Alive, local only, and least privilege, because sudo mysql e select a version, sudo ss lntp grep mysql d true. What we're doing there is we're checking that MariaDB answers locally and isn't advertising an unattended TCP port to the world. Next step, we have to use MySQL secure installation and create a dedicated WordPress user because root at everything is how side quests become breaches. So out of the box, Apache serves from var www HTML. It's the front porch of our Apache server. Drop a simple index.html in there. and you've proven the static path from the disk to the socket. Do a quick smoke test using curl i127.0.0.1 and expect a tidy 200 OK with a sensible header. That one-liner isn't just "is it up?" It confirms the listener is on port 80 and the vhost default site mapping, and that your file system perms aren't slightly trolling. Before you invite WordPress to the party, enable a few grown-up modules such as sudo at2en mod rewrite expires headers and sudo systemctl reload Apache 2. That line rewrites lets you do pretty URLs and app level routing. Expires and headers give you cache control and security headers right at the web server's edge. Think of these as equipping your web server with Batman's utility belt. Cheap, fast wins that prevent a lot of drama later. Before WordPress shows up with a suitcase of plugins, give the database a quick security tune-up. Think of it as changing the locks and labeling the fuse box before house guests arrive. First, we got to run the baseline hardening script sudo mysql secure installation on a fresh MariaDB. This walks you through the settings, root authentication, removing anonymous users, disallowing remote root, and dropping the test database. For this lab only, we're going to set the root password to password as specified, then change it later in a non-lab context. Like Gandalf with the keys to Maria, root should be local, accountable, and rarely used. So we got to create a least privilege application identity and clean up the schema. So create database WordPress database default character set UTF-8 MB4. Create user WordPress user at localhost identified by password. Grant all privileges on WordPress database to WordPress user at localhost. Flush privileges.
is